Hi everyone, welcome to Unit 3, Lesson 6. This is on the history of the periodic table. So we've been talking about the periodic table for a few days now, and what I wanted to do was kind of circle back and kind of show how we got to this point with three important scientists. Now, of course, there were many more scientists that were integral in developing the periodic table, but these three stand out. So let's take a look at our first one. So if we look at this down here on the lower right side, you're going to see that this looks like almost like a musical accompaniment. And the reason why I put that there was that our first scientist, whose name is John Newlands, he was an English chemist, he kind of related the fact that properties of chemical elements repeat every eighth element, and he compared it to a musical scale, which also contains 8 different notes. So if we look at the facts about John Newlands, so at the time, so this is around 1865, so kind of around Civil War time in the United States, but this was obviously not in the United States. So classified 62 of the known elements into 7 different groups based on physical properties. If you take a glance down at the bottom here, you'll notice that the group that is missing is the noble gases. Of course, in 1865, it's very difficult to get any information about noble gases, considering, number one, noble gases are not visible to you, so it's not like other chemical elements that are solids or liquids that have quickly identifiable properties, but also remember that noble gases are non-reactive. They have completely filled energy levels. So not only can you not see them, but it's very difficult to conduct an experiment with a noble gas because it doesn't react with other elements. Okay, so if we look at the second fact, he realized that pairs of similar elements existed, and they differed by a multiple of 8 in mass number. Now, this is relatively speaking. And then finally, he was the first to assign elements atomic numbers. Now, of course, he just assigned atomic numbers based on numbering them, the known elements from 1 to 62. So it was not based on protons because, of course, protons were not discovered yet in 1865. So he was the first to assign atomic numbers, but did not piece together that atomic numbers would be based on the number of protons like we know today. And then finally, and this is where that musical kind of component comes in, he referred to the pattern as the law of octaves. Octaves, of course, meaning 8. So every 8th element seemed to have properties that were similar to an element previously, so to the first element in that case. Okay, our second scientist is a person by the name of Dmitri Mendeleev. This is only 4 years later. So Dmitri Mendeleev is a Russian chemist. If you look on the side, there's a picture of what information was known at the time. So obviously this is not writing that is legible to us for the most part, but if you look here, you'll notice some commonalities to our current periodic table. So we have hydrogen, we have lithium, then we have beryllium, boron, carbon, nitrogen, oxygen, fluorine. So this is kind of like our second period on the periodic table. Notice that it looks like lithium is in the wrong spot, but he did notice that lithium, sodium, potassium, rubidium, cesium all had properties that were related to each other, just like fluorine, chlorine, and bromine, just like oxygen, sulfur, and selenium. So there's a lot of information in this table from 1869 that still holds true today. You can also see copper and silver here. You can see the 14th group on the periodic table, so carbon, silicon. And let's take a look. So he's widely credited as the father of the modern periodic table. He organized elements according to their properties. So this is similar to Newlands. So you might be asking yourself, well, why is Mendeleev's name attached to the current periodic table and not John Newlands? And it has to do with the next part. Mendeleev realized that there were empty spaces for elements that had not been discovered. So if you look at this periodic table on the right side, you'll notice that there are question marks over here. So if you notice, we have boron, we have aluminum, and then we didn't know what element would end up being here, but he knew some properties about it based on where it fit in his table. So this was really a leap forward to make the guess that, maybe all of the elements that we know today are not all of the elements that exist. And maybe in the future, we're going to find an element, and if we're looking for it, let's look for an element that has these properties, because based on the table that I'm putting together, this is what it should look like. And at the time, that was pretty remarkable. So it is often Mendeleev's name who is associated as the kind of organizer of the modern periodic table. And then finally, as I mentioned, he predicted properties about these unknown elements, and he did that again based on the other elements that he had grouped together. All right, we have one final scientist that we're going to talk about. And if you notice, first of all, now we start to look at a periodic table that looks very similar to our current periodic table. You'll also notice that by 1914, they had begun to identify the noble gases. So you see helium, neon, argon, krypton, and xenon. Of course, they're on the wrong side, or what we would consider the wrong side of the periodic table at this point, because we now know that they have completely filled energy levels. So they would be our 8th or 18th group on the periodic table, or our 8th group in terms of filling up electrons and valence electrons. So this person's name was Henry Mosley. He was an English physicist. And again, this is around the time of 1914. So if you're putting all of this together, this is just 3 short years after the discovery of the proton. And that is exactly what Mosley was recognized for. So he pieced together the fact that atomic number wasn't just a number in which, the order in which we discovered an element. It actually told us the number of protons that an element had. And again, this is coming just 3 years after the Rutherford gold foil experiment and really the discovery of the nucleus, the positively charged nucleus, and the idea of protons. He used wavelength data to identify the number of protons in an atom, and that's how he was able to make that comparison. And then he fixed the order of some elements that were previously placed out of order. So he recognized that it wasn't atomic mass that should govern the order in which elements are placed into the table. Instead, it's the number of protons. So where you see a couple of points on the table where atomic mass actually goes down, even though the number of protons go up, this was something that was corrected by Henry's recognition, or Mosley's recognition, that the number of protons was actually the determining factor in ordering elements on the periodic table and not the atomic mass. Okay, that concludes our mini lesson here on the history of the periodic table. If you have any questions, please feel free to reach out through an email or through a message on Schoology. Thanks, everyone. Have a great week.